Hello, everyone. My name is Khalil, and this is the papers entitled Convolutional Network and Moving Object Analysis for Vehicle Detection in Highway Surveillance Videos. We are from Universitas Syah Kuala, Indonesia. This is the outline. First of all, we would like to emphasize the contribution of our works. So moving object detection is an underlying task in so many applications. For example, moving vehicle detection, pedestrian detection, classification, and so on and so forth. In this paper, we are focusing on to detect the moving vehicles on the highway. This is very important, especially for the smart city application, and the specific application is the intelligent transportation system. In the proposed method, the improved background subtraction through bilateral filters, morphology, and connected component is employed to detect moving vehicles preliminary. And finally, the YOLO V3 will be employed in order to classify the detected vehicles. So as we know that YOLO is the very famous deep learning method in order to detect or classify the objects. This is the related works. First, Gaussian mixtures model, or GMM. So first, why GMM? Because GMM can or able to model the pixels from multiple Gaussian distributions. So GMM proposed the multiple distributions in order to model the pixels instead of the 1D or one dimension Gaussian distribution. Using multiple Gaussian models, we can successfully distinguish which pixel will be regarded as the background pixels and which pixels have to be regarded as the foreground pixels. While the GMM is very simple, but we still have the room for improvement. And here in our purpose method, instead of use the CPU, we utilize or we run or execute the program using the GPU environment. This is one short video in order to illustrate how the Gaussian mixed models works. This is the way we built the of the Gaussian. So GM is very flexible, but one of the challenge is the parameters of the multiple Gaussian distribution will be more than the 1D Gaussian distribution. However, as we will evaluate or we show on the next or subsequent slides, GMM is very powerful in order to detect the moving object. Besides or apart from GMM, we also uh, incorporate the connected component and morphology in order to extract very full or very complete uh, foreground region. So not only using the GMM in order to extract the foreground pixels, we also incorporate the connected component and morphology. Why? Because one of the advantage is CC and morphology will help us to exclude the small outliers and regard it as a background big pixels. And those two approach or these two approaches are very simple and low competition. So this is one of very simple example. This is the Gaussian mixer models without connected component and morphology. This is the Gaussian mixer models with morphology without connected component. And this is the Gaussian mixer models with connected component and with morphology. So as we can see that the region of the moving vehicles can then be extracted cleanly or more accurately compared with the original Gaussian mixer models and Gaussian mixer models with morphology. And this is the proposed pipeline because we would like to let the YOLO only classify the object or the moving object. So first, when we have the incoming frame here, we will use the GMM, improved GMM exactly, more precisely, and GMM will output the final ROI region. So instead of use this full dimension, we will give these pictures to the YOLO V3 classification. So in other words, we only give the moving area to the YOLO, and we will erase or we will remove the static region because this is not important for us. And finally, after we use this as an input, YOLO V3 will output the classification results like this, for example, car, and so on. And this is the YOLO V3, as I mentioned earlier, which is very efficient, and YOLO is very famous in order to detect or in order to classify the object. And this is the evaluation and discussion. In order to evaluate the results, we use the quantitative and the qualitative results. Quantitative results, we use several measurement units. So it's so-called the FP rate, specificity, FN rate, and also another important things is PWC, percentage of wrong classification or percentage of incorrect classification, and also the F measures is the precision rate of the harmonic mean and recall rate. And here, the comparison amongst the models or the methods, as we can see here that our final proposed method can outperform the previous results or at least very competitive. So for example, in terms of a percentage of wrong classification, the score is very small compared with the previous methods, okay? 3.5234. And in terms of F majors, our works can also outperform previous works. And another unit like the specificity, FPR, FNR, and precision, the result is also very competitive. And this is the bar charts in order to visualize the quantitative results. And our proposed final method is very competitive here. And especially for the FPR and FNR, the score is very small. So note that the FPR and FNR and also PwC, smaller value means more accurate results. Okay, so smaller value is better. And here we can see that is our proposed vinyl method can be very competitive. And especially for PwC score, our method can be very small. And this is the qualitative results, as we can see, and I also already emphasized on the previous slides that the final area can be very clean, and the small outliers here can be excluded or can be removed. And this is another video that we tested. This is the original GMM. This is GMM only with morphology. And this is the GMM with morphology and with the connected component. And as we can see, the area of the moving vehicles can be extracted clearly and also relatively more accurate than previous works. And this is another results. Okay. And I will give you I will show you the video of these results. So we can see that we only classify the moving vehicles, and we will ignore the static region. Okay, so we will only focus on the moving area here. As we can see that our work can extract the moving vehicles relatively very good, and then we pass this input to feed the deep learning networks. In this case is YOLO V3 version. Another data set is we use it, or we've obtained from the YouTube, and I will also show you the results in video. By only inferencing the moving vehicles, we will not get distracted with the static region. So this is our objective. The surveillance videos or the surveillance system only focus on the moving object only. And in this case, we limit our works on the surveillance highway videos. And it comes to the conclusion. We introduced a system for detecting vehicles on the highway in the study, and we used the improved Gaussian mixture models and YOLO V3 vehicle detection. And experimental results show that by finding an ROI from each incoming frame, the inference process can be more accurate and efficient. And in future works, we will evaluate more public data sets in order to evaluate the robustness of our proposed works. Thank you very much for your attention.